Log.
Hello everyone, welcome to Neural Engineering. I'm Dr. Daniel Schneider, your MetaU Artificial Intelligence professor, and today we'll be exploring the fascinating field of neural engineering and its applications in healthcare. Get ready for an informative and entertaining ride. Let's start with a quick joke to lighten the mood. What do you get when you cross a basketball player with a neural engineer? LeBron James wiring up the hoop. All right, maybe that joke was a bit of a stretch, but bear with me here. Neural engineering is a complex field that draws on a range of disciplines including neuroscience, electrical engineering, computer science, and materials science. It involves developing devices and systems that can interact with the nervous system, from the cellular level all the way up to the level of the entire brain. One of the key challenges in neural engineering is developing materials that are both biocompatible and electrically conductive. These materials need to be able to interface with the delicate tissues of the nervous system without causing damage or eliciting an immune response. Some of the materials used in neural engineering include carbon nanotubes, graphene, and even silk protein. Signal processing is another important aspect of neural engineering. The signals generated by the nervous system are incredibly complex and can be difficult to interpret. Researchers have developed a range of techniques to help make sense of these signals, including Fourier transforms, wavelet transforms, and machine learning algorithms.
Log.
Now let's bring LeBron back into the picture. Imagine LeBron dunking a basketball while wearing a brain-computer interface, BCI device. This device could allow him to control the ball using his thoughts alone, without even needing to touch it. BCIs have enormous potential for people with paralysis or amputations, allowing them to control prosthetic limbs or other devices with their thoughts. But BCIs are just one example of the incredible advances being made in neural engineering.
Log.
Deep brain stimulation, DBS, is another technique that has shown promise in treating a range of neurological and psychiatric disorders, from Parkinson's disease to depression. DBS involves implanting electrodes into specific regions of the brain and delivering electrical stimulation to those regions, effectively rewiring the brain. Overall, neural engineering is a rapidly advancing field with enormous potential to improve the lives of people with neurological and psychiatric disorders. I hope this lecture has helped shed some light on the complexities and possibilities of this exciting field. And hey, if you didn't learn anything, at least you got a few good jokes out of it. Neural engineering is a multidisciplinary field that involves the development of devices and systems that can interact with the nervous system. These devices can range from simple electrodes used for recording neural activity to complex brain-computer interfaces, BCIs, that allow for bidirectional communication between the brain and an external device.
Log.
One area of neural engineering that has shown tremendous potential is the development of BCIs. BCIs can be used to help people with neurological disorders, such as spinal cord injuries, multiple sclerosis, and ALS, regain control over their movements. For example, a BCI can be used to control a prosthetic limb or to enable a person to type on a computer using their thoughts. Recent advances in BCIs have focused on developing systems that can translate signals from the brain into more complex movements, such as grasping and manipulating objects. This requires a deeper understanding of how the brain encodes motor commands and how these signals can be translated into specific movements. Another area of neural engineering that has shown promise is deep brain stimulation, DBS. DBS is a surgical procedure that involves the implantation of electrodes into specific regions of the brain. These electrodes can be used to deliver electrical stimulation to these regions in order to modulate neural activity. DBS has been used to treat a range of neurological and psychiatric disorders, including Parkinson's disease, essential tremor, dystonia, and obsessive-compulsive disorder. DBS has also been shown to have potential in the treatment of depression and chronic pain. However, there are still many challenges that must be overcome in order to fully realize the potential of neural engineering. One of the biggest challenges is developing materials that are both biocompatible and electrically conductive. These materials need to be able to interface with the delicate tissues of the nervous system without causing damage or eliciting an immune response.
Mission log.
Researchers have explored a range of materials for use in neural engineering, including carbon nanotubes, graphene, and even silk protein.